So the outside derivative for the chain rule is just the power rule. You leave everything inside the same. You don't mess with it. So subtract 1 from the power, then you multiply by the derivative of the inside. So I'm going to just use a quote right here so you know that you have to take a derivative of this. Okay? So this derivative is going to be a pain because you got to do a quotient rule. Or you can force a product, but it's not going to be worth your time. That's all right though. We'll be fine. Let me find the formula because I always forget where the minus goes. Okay. All right, so the formula for f of x over g of x derivative is equal to g times f prime minus f times g prime over g squared. There we go. Makes me feel better having it handy. Okay, so f and g are right there. So that's going to be on the next step. So the first part is done. Just leave it alone there. We can do algebra or whatever towards the end. Let's focus on that quotient. I'm going to erase this because I don't need that bar there. Okay, so this guy is going to be times g, the bottom, so that would just be itself. The bottom would be squared, so 1 plus sine x squared, that's the g. All right, so 1 plus sine x times the derivative of the top, which will be, well, I'm going to go ahead and show the quotes this time, just so we have more steps, minus f, which is cosine, times derivative of g. I'm going to go ahead and move this to the middle because it bothers me, not because it matters. Okay, so here we go. Again, this first part is going to be chilling there for later. No, don't even worry about it. Derivative of cosine is negative sine, right? So we're going to have 1 plus sine x times negative sine x minus cosine x times the derivative of this. Derivative of 1 is 0, derivative of sine is cosine, so that becomes another cosine. So now we're done with all that. Derivative is now finished. Technically, this would be your answer, but it looks like garbage, so we should do some algebra. Let's look at our answer choices to get an idea how far they went, because we can play with algebra all day long. Let's see here. It looks like, yeah, they multiply this out and combine like terms. And multiply, then this bottom part, 1 plus sine, right? That's the same as this. So this would become a cube for sure. You see that? 1 plus sine times 1 plus sine squared is 1 plus sine cubed. All right, so I'm going to go ahead and do that on this step. Multiply this denominator in here. 1 plus sine, so distribute that, that'll be a negative sine x minus sine squared. Let me put the square over here, preferred. Minus cosine times cosine would be cosine squared x over 1 plus sine x cubed, right? You guys still with me here?
Yeah.
Yeah, I'm still with you.
Notice how they're all negative. So let's go ahead and pull this minus out over in front. So now it's -3 because I'm pulling it out completely to the front, leaving us with sine x plus sine squared plus cosine squared. But what is cosine sine squared plus cosine squared? That's our basic trig identity, right? The original. So from pre-cal, what does this become?
Maybe it's 1.
Yeah, that's a 1, right? It's one of the main pre-cal identities that created all the other identities for the most part. So now we got sine x plus 1 over 1 plus sine x cubed. Because I don't need that big bar anymore. But notice how this is the same thing, right? So this should cancel one of those. See what I mean? Should. But let me check everything before I go further. Because the answer looks weird. Let me see here. Oh, shit. Made a mistake. Check it out. This should be a square right here, right? Which means this would be 2, so this would change to a 4. Do you guys see that, or do you want me to show you an extra step? Do you see how this became a 4?
Yeah, I see it. Now
This
that
is
you
one.
put the squares there, I thought something was hinky, but I couldn't peg it.
Yeah, let me fix this for you.
That's like, okay, so like it's like the math fits out, but okay, yeah, I think it's because you and me were trying to do it in our heads.
There we go. Now it's all fixed. Is there any steps that I lost anyone at, and because of my error?
You were talking mostly. You didn't lose me.
You got 1 from. You didn't. I'm just a little confused how you didn't get a -1.
Oh, from here?
Yeah.
Well, we had a negative. All of them were negative originally, right?
Yeah.
So I factored a negative out of all of them and put it in front.
Oh, okay. Yeah, I didn't notice that.
So
Okay.
now they're all positive. So this becomes plus. So now this will cancel one of those. So now I have -3 cosine squared x over 1 plus sine x cubed. And that's as pretty as it's going to get.
Sorry, you lost me. How did it become a 4? I know you were missing the 2 or the squared.
Oh, okay. So right here, let me show the extra step before it becomes a 4. So originally it was a 2, right? But if I separate this square, see how there's a square on this thing here?
Mm-hmm.
You square the top and you square the bottom. So this becomes 1 plus sine x squared. So this times this would be 4 of them.
Okay, got it.
And then one of the 4 is canceled by this one, so that leaves you with 3. Any other questions on 14? Answer's A. If you at least show me this setup here, that you show me that you understand the chain rule, but mess up along the way, this at least shows me you know what you're talking about. If you mess up somewhere in here, it shows that your algebra is weak, right? So at least set it up, right? All right, let's go to a different one.
Hold on just a second.
No, wait.
Thank you.
Yeah. Okay, so 15 is very similar. I'll let you do that one. It'll be a product rule that has a chain rule along the way. So it'll be easier than the one we just did, but a similar idea. 16 looks like a triple chain rule, I think. Let's do that one. That one looks harder. Like, notice how we have a cube outside, cosine, and then an inner function. So that's 3 functions. Do you see what I mean? Let me write this one down. 16. Find the derivative with respect to time of y equals cosine cubed of pi t minus 12. Okay. So here we go. So the derivative, right? Derivative of y with respect to time, in other words, y prime, is going to be, so the outer function is the 3. So you bring down the 3 and subtract 1. Leave everything the same. Then you have to do the other derivative. So multiply times the derivative of the inner function, which is cosine. Derivative of cosine is negative sine of this nonsense, pi t minus 12. Then you multiply by the derivative of the innermost function, which is derivative of this, pi t minus 12, which would be pi. So let me do that again, but this time I'll show some quotes here. Let me show an extra step. And I'm going to use the prime because I feel like that makes more sense when we first talk about triple chains. And if that made sense, great, then you understand the chain. But if it didn't, let me do this for you. Find y prime. So y prime will equal derivative of the outside. So you bring down the 3, subtract 1, times the derivative of this guy times the derivative of this guy. You see how there's a triple chain? The chain rule says if you have a function composed with another function, right, the derivative is the derivative of the outside while leaving the inside the same, multiplied by the derivative of the innermost function. So do you see that the outer function of the original is the cube? So there's 1 function, 2 functions, 3 functions. Is that clear? Cubic cosine pi t minus 12. So it's like we have, in this scenario, we have y equal to f of g of h. You see what I mean? Is there any questions about that before we start doing the derivatives? Because the key is seeing what this means, right? My derivatives are whatever, but understanding what's happening is what matters. You guys are all pros, is that what you're saying?
What would
I
you
kind
do?
of see that.
Sorry. What would you do in a situation where like there was exponent, say cosine cubed, and then in the outside the parentheses there was another exponent?
I would probably try to combine the exponents, because if you have a power to another power, you can use algebra to combine them. But you could have more than 3 functions composed. You could compose it as many times as you want. It can get real ugly. Like you could have something weird like, I don't know, sine fourth of e to the square root of x squared plus 7. You could create some nasty function, which would be 1, 2, 3, 4, 5 composed functions. Just like I just combined 5 functions into one, like those little nesting dolls. You know what I mean?
Oof.
So you would just have to follow the rule, right? You start with the outermost function, cubic, then the next most outermost function, cosine, and then the innermost, pi t minus 12. So you have to identify what is the outside, middle, and inside. How many are there? Okay.
Yeah, it's just easy to overlook sometimes.
Yeah, sometimes it's not clear. Like it might look like, oh, that's just one function. You might just do this part and be done with it, right? But that's wrong. So be careful. But once you set it up, you just do these derivatives and you're done. You just got to multiply them. So derivative of this guy is going to be, let's go ahead and do it down here, I guess. So the first one's done, the outermost function. Multiplied by this derivative, which would be a negative sine of pi t. Then multiplied by this derivative, which is just a pi. So at this point, the derivative is done. Just multiply all this out, and you would get negative 3 pi sine of pi t minus 12 cosine squared pi t minus 12. That's as pretty as it's going to get. So here it is. Negative 3 pi cosine squared sine. So they put the cosine squared first, which is fine. Same thing. The answer would be C. Is there any questions on 16? So this is a really complicated chain rule. All right, we'll move on to implicit derivatives. Find dy dx. So you got to solve for this. They're going to give us x cubed plus 3x squared y plus y cubed equal to 8. So we're going to do d dx. Yeah, they said x, right? Yep. d dx of both sides So derivative of this first one, since it's all the ones that just have an x by themselves, will be easy. It'd just be the usual, usual approach. If there's a y involved, we gotta add that dy dx. Okay. This would be a product rule, so that would be the hardest part. First and last terms will be, big deal. So d dx of x cubed plus d dx of 3x squared y plus d dx of y cubed equals to 0. Derivative of a constant with no respect to whatever will always be 0. So derivative of x cubed, no big deal, right? Derivative of this is going to be a product rule. So that's the hard one. So that will be derivative of the first times the second plus the first times the derivative of the second. And then derivative of y cubed, you treat it as if it was an x, but then you tack on the implicit piece. Is there any questions on that first two steps there? There's the first derivative since the third there. I separated them just so you can see. Okay. All right. So now we need to get anything with dy dx on one side, everything else to the other side. So here we go. So I'm going to subtract this first term and second term to this side and leave everything else on the left. So that would mean that I have 3x squared dy dx on this side, this left-hand side, equal to negative 3x squared. I'm going to move it over by subtraction, and I'll move this term over as well. I skipped a small algebra step there. You guys still with me here? What happened? I just subtract minus 6xy on both sides. That's where this came from. Minus 3x squared on both sides. That's where this came from. Some people like to think about it if I move a term to the opposite side of the equals, I just swap the sign. Move it over, negative. Move it over, negative. That makes more sense. Cool. Whatever. Anyway, so factor dy dx, and we're pretty much done. That's the goal. Find this guy. So dy dx factored leaves us with 3x squared plus 3y squared equal to all this nonsense. Divide this on both sides and we're done. Make this a little prettier. So finally that's gone. So dy dx is equal to this quotient on the right. So that'll be negative 3x squared minus 6xy over 3x squared plus 3y squared. You could factor out a negative 3 on top and bottom if you wanted to. So I could pull out a minus 3 and a 3 from the entire thing, leaving me with this. Right? Oops, shit. Forgot to pull the 3 out. So these cancel, leaving you with a negative in the front. That's as far as you can go. And I think that's what they got. Let's see. All right, see the minus in front? X squared plus 2xy, positive because the minus is in front. X squared plus y squared. So answer is D, I guess. Any questions on 17?
I think I just missed the part, like second to the last part.
Mhm.
With those
Here?
negative 3.
Oh,
After
yeah.
that, I think that's where I missed you.
So you factor -3 from the top, so that becomes just x squared, right?
Okay.
That becomes +2. And these both have 3, so that's here. Had 3, I guess. 19 and 20, we've already did examples in class. Remember, we had a water falling in a puddle, creating the radius. This is the same thing, just different numbers. We also had the balloon. Remember, we had the balloon increasing with air. That's just another sphere problem. So we've done these. So I'll leave these for you, so I don't do all your review. Let's go to 21 and get to the inverse stuff. 21, 22, 23 are all about inverse trig. So notice how we have, so this is the outer function, cosine inverse, and an inner function. So you apply the formula for inverse, but then the inside has to go where the argument goes. See how all the arguments have that inside? So we need to, so you have to have the formulas handy for inverse trig. Let me find the formula sheet. Oops, I don't remember. Here we go. All right. Let me write down the problem first.
Before I forget, Jack, you forgot to apply my combinations to the review test.
Okay. Oh, yeah, sure. Oh, well.
Thanks.
Find the derivative of y with respect to x. Y is equal to this. Now the formula, the derivative, well, give you the formula over here. So if y is equal to cosine inverse of x, then y prime is equal to, let me pull up the formula for you here. Cosine, I think has a negative on it. Yeah. Negative u, or sorry, in our case it'd be x. Negative x prime, the derivative, whatever's in there, over the square root and 1 minus x squared. So this argument is like the big X, right? This X here. So we're just going to plug this in there and there, up top. Okay? So the derivative will simply be negative derivative of the argument over the square root of 1 minus (1 minus 5x squared plus 4 squared). Does that make sense? I'm just following the formula verbatim, right? So the formula actually takes care of the chain rule for you, which is kind of cool. So just do this derivative and you're done. So that would be what? Negative 10x. Yeah, that's it. Over the square root of 1 minus this weirdo argument. So the inverse trig derivatives are not too bad because the formula kind of does the heavy lifting for you. So there it is, -10. So this would be the same. So use the sine inverse formula, but remember that this thing inside is the argument. Same thing with tangent. Use the tangent formula, but remember that this thing inside, including the square root, is the argument. All right, so I'll leave those to you. Let's see here. I know a few people had some homework questions. Anyone want to do some homework problems? And before we do that, did you guys have any questions on what we just did today for the review?
Test is gonna be only covering chapter 3.
Yeah, just 3. So it'd be derivatives over and over again, all of them. Only the first one will be the limit, the definition of a limit with a derivative. The rest will be just using the formulas.
Got it.
When's the test gonna be due again?
I mentioned it last time. Let me see what date I put. I forgot.
Yeah, I forgot too. It's one asking.
Let me look at it.
The 31st.
Okay.
Okay. When are you gonna open the test then, this weekend?
It's already open.
I'm looking at Canvas. I only see the test 2 review. I don't see the full test 2.
Let's see. Let me check. Oh, right. Yeah, let me fix that for you. Thanks.
Uh-huh.
I see what you mean.
Also, will the review, will the test have different kind of questions with more like definitions, or
It should
will
be
it-
similar to the review.
similar as in like almost the same, or
Like same types of questions. Like
okay?
So is there a deadline for the review or no?
Not posted.
Let me see. Hold on,
Um,
I'm currently unlocking the exam. Give me a second.
I'm staring at this review. It says no due date.
Yeah, I guess it
So
currently has none then, but I'll put one in there.
But we're gonna skip the review right to the test.
So exam 2 is due 31st. There's a date in there now.
Uh-huh.
Let me open it up for everybody to see.
And for the exam, it's just only one try?
Yes, the actual exam you get one try. That's it.
Okay.
How many questions are going to be on the exam? I don't know if you answered that already.
Let me check. Now that I have it open. Try not to put the test on April Fool's Day because it causes confusion.
That would be
that would be pretty funny having a test on April Fool's Day.
That would be, honestly.
Yeah, so there is no test. I'm just kidding.
Great.
Let's see here. Number of questions, right? It's gonna be 50 questions. I'm just kidding. It looks like 13.
Okay.
13 questions, similar, same types of questions as the review. They're just different functions and numbers.
With
That
2
makes
hours
sense.
to complete.
Let's look.
oh my goodness.
An hour and a half. But I'll give you 2. It's fine.
I have a question about the
What's up?
will there be formulas provided for us, like with the computer?
No, you can make. Yeah, I won't provide any, but you can bring one page of your formulas, front and back. So just formulas, definitions. That's it.
And you have to be able to read them with just your eyesight. You cannot have a magnifying glass. I tried that.
I don't recommend that. Let's see here.
How many formulas did you have? You have to have a magnifying glass. Holy cow!
I have an old microdot printer. I can print the old World War II microdots or something close to that. Yeah, pretty much all of them. I had a book's worth of formulas on a page, and it just looked like solid lines. But when you held up a magnifying glass, it was double lined formulas.
You shouldn't
That
need more than
was-
one page for this test. There's not that many derivative formulas. Maybe for the final. Or
This was back in algebra when we were doing a big algebra thing. When I had a bazillion formulas and it was over like 3 chapters or something like that.
yeah, if it was like the entire class final thing, sure, makes sense.
It was something like that.
In Cal 2, I could see people doing that, but Cal 1, maybe not.
I had a front and back of done of that.
Do they help?
The formulas, yeah,
Yeah.
especially for me since given my mental problems. But yeah, the formulas help a lot. It helped a lot. But that was just the hard part, was finding back.
Screwing around anymore. All right, so drdt. Want to divide all this stuff over here, so that would be equal to dv dt times, just to make it look prettier, I'm just going to put it over here on the side, 4 pi r squared, right?
Yeah.
All right, so we know the change in volume over time, so plug that in and plug the r, and we should get it. Let's see. So the change in rate and radius over time should be 800 centimeters cubed per minute times 1 over 4 pi times 50. So this will be the first one, 50 centimeters squared. All right. So this will cancel 2 of those. So 800 divided by 4, what is that, 200? So this would give us 200 centimeters over 4 pi. Oh, actually, 4 is gone, sorry. What's 50 squared? Is that 2,500 or I forget. Right? 50 times 50, that would be 25 times.
That's 2,500.
Yeah, okay. Just want to make sure before we go any further. So reduce this. 2 zeros are gone. So you got 2 over 25. So that should be our answer. 2 over 25 pi centimeters per minute.
Maybe that's my error, is that I did it in the actual number. Like, sometimes it's picky about whether you have it in like with pi in it, but I did pi calculate it out.
Oh, you rounded the pi or multiplied by pi there, saying?
Yeah.
Yeah, I think it says, let me look at, does it specify? Oh, it doesn't say exact, but it doesn't say rounding either. So if it didn't say anything about rounding, then you should stick with exact.
What homework and what question is that?
So that's number 7 from 3.6, I think it was.
3.6, okay.
Took that form that you have.
3.7 is 3.7 homework.
I think in the book it's 3.7, but in the homework it's 3.6 for some
Oh,
reason.
okay.
It's confusing. I think I made this homework before they updated the book. That's why.
It's just the form that you have right now. I mean,
So I can't hear you. What'd you say?
it took that form that you have right now.
Oh, it did?
I tried 2 other ways and it accepted that.
I see. So you're good?
Are you talking to me?
Yeah.
Oh,
So
yeah, mine's good. I did this earlier.
oh, okay.
Just letting you know, whoever needs to know that it wants it in that form.
Okay. Okay.
I'm good now. I think it was me plugging it in it's like the exact number difference.
Okay.
But it wasn't my original question. It was somebody else's original question. But
Anyone? I guess does anyone have questions on this or on
No.
part 7, number 7?
No.
So for 65, you do the same thing. You just plug in 65 here. That's it. To finish part A. Part B says explain why the rate of change of the radius of the sphere is not constant, even though dv/dt is constant. Yeah, since then this says because r is squared, then it won't be constant. It's going to be growing pretty quickly as you pump in air. Even though you're pumping air at a constant rate, the growth is r squared, right? The radius. Okay. You guys have any other questions?
No, sir. I'm okay. Okay. Good night, sir.
Yeah, Roberto.
All right. I'll see you next week.
Yeah, all right. Anyone else have questions, or you guys good?
I think I'm good.
All right, if you have none, you can head out, and if not, I'll stay and see if anyone's stuck on anything.
Okay. Good night.
I do need a little help on 2.7. I posted a picture on the chat.
3.7. Let's see here. It's not a virus, right? I'm just kidding. That's number. What number was that?
This is number 2 from 3.7.
Oh, number 2. Okay. Yeah, I see what you're saying. From 3 point something else. That's a different section, right?
3.7.
Yeah, there it is. Let me open it up.
I just did that like 15 minutes ago. And I had to do it like 3 times.
Yeah, for me, the issue is I get dyslexic, so I'm like, it's upside down and negative. It starts to mess with my head. That's my issue with that question. But let's see here.
Well, I tried being sneaky with my algebra, and then I think I just screwed myself in there.
I see. Okay. Yeah, I need to get that formula. I don't have it on me. Give me a sec.
I got it to work with the product rule. It was you that asked that, right, Felipe?
What, I'm sorry?
I was able to pull it off with product rule eventually.
On the one that I posted?
Yeah, by treating, I think so. It was from 3.7, right?
Yes, that is.
Yeah, first thing you do is take the derivative. Then you're going to plug in f of, let me get the calculator out. Hold on. Give me a second.
It's in F prime. What kind of formula is this? I'm sorry.
It's the formula I gave you right at the beginning for right at the beginning of this in the lecture of 3.7 as the definitions.
Okay.
But give me a second.
So you want me to
Negative.
share my screen real quick? I have it.
No, yeah. Hold on a second. Hold on.
Okay.
I was just wanted to check where this number came from. Hold on.